Okay. Probably she should start the YouTube after I do attendance, but okay. We are missing Gabriella and I was just about to mark her absent. Okay, Ariana's here. Okay, I think we're good. All right, so we're going to go ahead and get started. I got one. Kamari Daniels. Also right here. Okay. All righty. So just a little backtrack. We've been talking about ecosystems and relationships within an ecosystem. And last class, we looked at the energy pyramid. Let me see if I can go back here for a minute to our discussion. Okay, I'm gonna take it. Move it on student view. All right, so we watched the video last class on productivity in the ecosystem, and we're going to deal a little bit more with this energy pyramid today. So we're going to look at where the relationship between food webs and food chains. So again, looking at this, you always need to remember that the sun is the original source of energy for everything. And the only thing that's able to absorb the energy are the primary producers, which are our plants. They're always going to be at the beginning. And then we use a pyramid to represent the organisms that have the biggest population. So the producers are the most abundant species on the planet. And then you have your consumers. You have primary consumers, secondary consumers, and tertiary consumers. So this parent, and then you're looking at fewer and fewer organisms as we get to the top. And then we have our decomposers, and notice that the decomposers are associated with every level because all living things have to die. And the decomposers are able to break them down and return them back into the system. So we have this continuous cycle of nutrients all the time. All right, you all did a good job of answering this question about photosynthesis and the importance of all of these things, but I'm just going to go over it quickly with you. So the equation for photosynthesis, and I corrected some of you last time, is carbon dioxide plus water. And then you have this arrow, and technically over your arrow, that's where your sunlight energy should be placed when you're writing an equation. And I didn't discuss that with you all last time, but you should know that when you're writing a real equation for photosynthesis, sunlight energy usually sits on that arrow, as well as chlorophyll, because chlorophyll is the enzyme. So there's two things about that equation that are necessary in order for that reaction to take place. If you don't have sunlight, it's not going to take place because it activates the chlorophyll. And the chlorophyll is the enzyme that actually breaks down the molecules so that we can make the glucose. So when we asked the importance of sunlight, some of you said, rightly so, said that the sunlight energy activates the equation. Okay, the equation will not take place at all without the presence of sunlight. Temperature. All activities function at an optimal temperature. So the warmer the temperature, some of you actually said, the faster the reaction will go. Cooler temperatures is not that it won't happen, it'll just happen slower. So the correct temperature or optimal temperature is necessary for photosynthesis to take place. Our nutrients are the things that are going into our equation. So that's the carbon dioxide and water. And we're the carbon dioxide was one of the things on the variables that you had to talk about, but the carbon dioxide in the atmosphere is important because it is the main one of the main variables in that have to go into the equation. But in addition to carbon dioxide, the other one is water. This doesn't happen without water. So it's carbon dioxide plus water. And then the enzymes break those bonds down and rearrange those molecules. So when we make glucose, we're not inventing something that we didn't have before. All we did was rearrange the atoms to form something new. Okay, so we created glucose. We created a sugar that, and in the new bonds that have been formed in making that glucose molecule, then we've created the food, the nutrients for the plant, because the plant needs food too. So it makes its food and then it uses its food. So then it uses that to break down the glucose to do all of the energy processes that it needs to do. Okay, so that's how you had to look at that equation. Take that equation in reverse. So when we take the glucose now and we break it down, that's respiration. So respiration doesn't happen without oxygen, and oxygen was given off as a waste product in photosynthesis. So it was sent back into the air. So for respiration to take place, the glucose is usually already in the body. You breathe in the oxygen and you combine those. And there again, there are enzymes that are necessary for respiration. Otherwise, that reaction doesn't take place either. Okay, so all right, so everybody did a good job of explaining that. And I'm not gonna go, let me see if I can get all the way to the bottom and there we go, we can go next there. Okay, so here we are. So today we're going to look again at the energy structure of our system. And again, looking at that pyramid. So if you can keep a copy of that pyramid, that would be good, because we need to look at our producers versus consumers. All right, so we're going to go back and review the vocabulary. Always keep these vocabulary words in mind: abiotic and biotic factors. Abiotic are all the non-living factors, so that would be the sunlight, the air, the soil, the water. All of those are necessary. So abiotic factor for photosynthesis that was important was the water and the sunlight. And they also mention here temperature, humidity, and all of the nutrients that are in the soil are important. The weather can go with temperature because it could be windy, rainy, depending, and those things kind of move nutrients and soil along. So those kinds of things are important as well when we talk about abiotic factors and living things. Everything else is a living thing, so that includes the plants, the animals, and the bacteria, and our decomposers, which are kind of classed with bacteria sometimes. So keep those two vocabulary words in mind. The other words that we're going to be looking at are right here, primary producers and autotrophs. Autotrophs, the prefix auto means self, and the troph is feeding. Okay, so they are self-feeding as opposed to heterotrophs. So heterotrophs have to take their food from other organisms. Okay, so we're looking at those, and our autotrophs are always, always, always our green plants. Okay, the other words that we need to look at is trophic levels. So the pyramid that I showed you earlier represents the trophic levels. Trophic again meaning feeding. What level feeding levels do we have? So our autotroph makes its own food for photosynthesis. No other level does that, just just the green plants. If an organism cannot make its own food, here's the other word I was explaining, heterotroph. And I'm pointing these out because these are your vocabulary that you need to know. So I don't know if you're recording them or you just go back to the first page and read them over, but you need to make sure that you have an understanding of these vocabulary words. All right, so our heterotrophs are the ones that have to take in their own food. The consumers is another word for that. So we have herbivores, which are the first level of consumer or primary consumer, because they eat the plants. So they are the first level. And then you have your carnivores, which are your secondary consumers. So the animals that eat the animal that ate the plant is a carnivore or a secondary consumer. And then they're the ones that eat the secondary consumers are tertiary consumers. Okay. Um, then they go, they go on to talk about detrivores, and they can also be our decomposers. Okay, and they're the ones that break down or decay all of the living things. When they decay, they add nutrients back to the soil, gases back into the atmosphere, that sort of thing. Okay. All right, so we're going to look at a Nearpod for a minute. So I'm going to leave this for a minute here and come back to that. And which, all right, let me look at this one first. All right, I'm going to give you the link just in case you can't hear it, but I'm going to play it. Okay. All right, so you should have the link for this Nearpod, and this one is just a video. This is not the one, the Nearpod that I'm going to show next, but it's going to stop and you have to participate. Okay, I get.
When we were little, we loved nature shows. One reason was because we didn't have cable, and it was one of the few things we actually had a TV signal for that didn't require you to dance around with TV antenna for reception. But the other reason was that, of course, it was cool science. It often showed animals that we couldn't see in our own backyard doing some awesome things. But then it would be a little traumatizing when inevitably some predator would walk in and gobble the other. Prey are often shown in nature shows because they're all part of nature's food chain. A food chain starts with a producer. A producer is an organism which means that it makes its own food.
Okay, apparently they do pause it. All right, so go ahead and answer that. And we've kind of gone over these. And the advantage of looking at my view instead of just your view is that you can almost see where you're making the wrong answer. And right now, so I need everybody to participate. Another name for producer, another name for producer. They make their own food. All right, so like I said, you can pretty much, by looking at the responses on my page, you can pretty much see where the correct answer is going to be. All right, so C, autotrophs. Remember, auto means is the prefix for doing it by themselves. They are self-feeding because they make their own foods. So plants, so remember that, write that down. You should be taking notes or something. Write down that plants are producers and they are autotrophs. Again, autotrophs means self-feeding. All right, I'm moving on.
A plant, for example. The plant is eaten by a primary consumer, this grasshopper here. Consumers are heterotrophs, which means that they need to feed off other organisms. The primary consumer is eaten by a secondary consumer, this frog. The secondary consumer is eaten by a tertiary consumer, this snake. And the food chain can keep going. Notice how the arrows are supposed to point in the direction of the one doing the eating, which makes sense because that's the direction of the energy flow. You can also arrange the same food chain into an energy pyramid.
All
The
right.
producers are at the base here.
All right, I'm going to stop it because they didn't stop it, but that's an important point that you need to remember. All right, because you will have to draw a a food web or a food chain, and it matters which way you draw the arrows. So the arrows go from the thing that is eaten to the thing that does the eating. So that's an important point. So in other words, when you're looking at this, not only is the energy flowing this way, but this arrow going from the producer to the grasshopper is telling you that the grasshopper eats the grass. All right, the frog eats the grasshopper because the arrow is pointing at the thing doing the eating. Okay, so if you do it, you put your arrows in the wrong place, mark it wrong.
You can also arrange the same food chain into an energy pyramid. The producers are at the base here. In trophic level 1, they actually contain the most energy. What's crazy to think about is the primary consumers here in trophic level 2, they actually only store 10% of the energy from the producers. Let's say the plant here has 10,000 kilocalories. That's an energy unit of energy. Well, the next level here, the primary consumers in trophic level 2, they would only store 1,000 kilocalories of energy. So where did the rest of the energy go? Much of it is lost to heat or undigested. If you go up to the secondary consumers in trophic level 3, that would be only 100 kilocalories of energy. So as you go up each trophic level, it's roughly only 10% of the energy from the trophic level below that will be stored. Back to our food chain. Notice that domino effect. If something you go up each
all right, I wanted to pause it. All right, I want to pause it there. So plants take in 100% of the sun's energy and they use that energy. Okay, so their life processes have to require the energy, and some of that energy, 90% of that energy is used. What is stored in the plant is only 10% of what it originally got. So when the next organism feeds on it, the amount of energy that is available to it is only 10% of what it originally consumed. And, or in the case of the plants, made, because they make the food. Okay, so they make the food, use it for their, because they have to carry out metabolic processes, and that requires energy. And what they don't use, they store. And then what they store is what you get your energy from when you eat it. So the grasshopper eats the grass, it gets 10% of that 100%, it's only going to get 10% of what originally was acquired. And that's important to remember, okay? It's getting 10% of what was original, what was stored, okay? 10% of what is stored in that organism. All right, so then the grasshopper eats, and then it has life processes that it has to do. And so it's going to use 90% of its energy again, and it's only going to store another 10%. So the next level is only getting 10%. So I think the pyramid that I showed you, the decimal point kept moving 10%. So that by the time you get to the top, it's like 100% of what the original amount was. And that's important to remember because they're going to give you some math problems. You're going to actually get numbers like she gave you, suppose there was 1,000 kilocalories made at the beginning. So the next 10% of that for the next level is 100. And 10% of the next level is 10. And by the time you get to the top, it's point 1. Okay. So you got to remember that it's only 10% is available to each level. All right, I'm going to let it finish.
10% of the energy from the trophic level below that will be stored.
All right, so now I just explained all of that. So answer that question. Any level above an energy level can only store how much? All right, everybody needs to respond because it knows how many people are logged in. So I should have 100% response, not 60%. If everybody responds, I'll get 100% here. Everybody, if you're logged in, you need to answer. And everybody's logged in. All right, so we just talked about it. It should be 10%. They can only store 10% of the energy from that they consume. So you eat a whole organism, but you don't get all of that energy from that organism. Okay. You use some of it. I think she explained too that some of it is lost. Your body heat radiates heat. So some of it is lost to heat to the environment and the rest of it is used for body processes. Thank you. I got 100% now.
Back to our food chain. Notice that, like a domino effect, if something is removed, let's say the grasshoppers, you can harm the others because they might not have enough to eat. You really have to consider the relationships among organisms in a food chain. In fact, even if you took out the apex predator in this particular food chain, which is the snake, you could end up with an excessive population of frogs. And so many frogs that it's possible they wouldn't have enough grasshoppers to even support them. This is actually not a very good model because in real life, this snake probably doesn't just eat frogs. It probably eats rabbits, birds too, because an ecosystem doesn't typically have a single food chain. Instead, it has more of a food web. A food web is made up of multiple food chains that interact together. So notice how now we have multiple food chains here tied in with our original to make a food web. The beauty of a food web is that it shows more interactions among a variety of producers and various level consumers. It also can show biodiversity. Biodiversity is the variety of organisms, all types of organisms, living in a given area. The size of the area that we're talking about, as well as the climate of the area, directly affect the biodiversity that is present. Biodiversity can contribute to the sustainability of an ecosystem. What I mean by that is, let's say there was a decrease in the amount of small birds in this food web. Well, it's likely that will be harmful to other organisms. However, it is not the only thing that the snakes feed on. They have other options because of the biodiversity.
Okay. I'm going to take this out for a minute. Let's do student view. All right. Why do you need to write a written answer for this? I'm going to give you a minute to answer that. And then I'll switch back to teacher view so I can see who answered and who didn't. Again, I need an answer from everybody. All right. So why do you think the food web can recover even if a population of one of the heterotrophs is reduced? Remember, food web shows all of the feeding relationships in a given area. So like she said, if we take the snake out, why would taking the snake out not really disturb a food web? It might disturb a food chain, but why would it not disturb a food web? All right, so I'll give you another minute to jot down an answer, and then I'll switch so we can look at what you had to say. All right, so let's look at some of these answers. All right, man, don't. So if you don't have an answer up here, I still need you to answer. There we go. Thank you. All right, so I think the food web will recover for population loss because other organisms working to balance the entire food web. So okay, that's good. Right, because food is multiple connections. Okay, eventually to change in the population. Okay, that's not exactly the answer to the question, but that's a true fact. I think it will recover since it would have another species to take its spot. Okay. All right, folks, what happened over here? Jada, Deborah, Ariana, Isadora. Isadora, you're off camera. I don't even know that you're still with me. All right, but I need all of y'all to participate on these things. So I'm checking. All right. So again, what she's saying, when we look at a food web, most organisms don't eat just one thing, just like yourself. You don't have one kind of food. Okay, you eat several different things. So if you like McDonald's and all of a sudden McDonald's went out of business, you would switch to maybe Popeyes or something like that. You wouldn't starve because you would switch from eating hamburgers to eating chicken. And you have a variety, and that's available to you. Same thing in an ecosystem. They have a variety of food sources that they can choose from. So that's what they do.
The snakes also eat rabbits. So because of this biodiversity, the ecosystem might be more resilient to changes such as these and possibly recover. However, these changes can still have detrimental effects, and it's why it's critical to protect ecosystem biodiversity. High biodiversity has a lot of other benefits. It can include economics, and we'll need another video to really touch on all the benefits of high biodiversity. So, if we were to ask you which of our examples here had more biodiversity, our food chain here or our food web, you would definitely want to pick the food web. One last thing, there are some organisms that we left out of our food webs and food chains, but they're kind of a big deal. Decomposers. Decomposers are heterotrophs since they do eat other things, even if the things they're eating are dead. Decomposers include organisms like bacteria and fungus. Technically, if we were to draw them in, then every arrow here would eventually point to them.
Okay. All right, we're not going to answer that question. All righty. Actually, let her do. All right, it's funny. We just watched The Lion King the other day because the passing of Mufasa. Okay, but that's something you have to keep in mind. Let me go back because that's kind of funny, but it's not funny. That you need to remember the circle of life. If you take something out of the circle is broken. As long as the circle is complete, it moves, it cycles continuously, and everybody in the circle functions and does well. You can still use The Lion King as an example. Um, you had an overpopulation of hyenas and they ate up everything, and next minute you knew there was no food for the lions. So taking one thing out of your circle affects everything else. So we're going to look at that too, because they're going to ask, we're going to give you pictures of a food web and ask you what happens if you take this organism out, and you're going to have to look at all the other arrows and say that this one is going to become overpopulated, and if that one becomes overpopulated and there's more of them to eat. For like the example she gave was the snake, the frog, and the grasshopper. You take the snake out, there's not a lot of snakes to eat the frogs, so the frogs can reproduce and reproduce, and nobody's keeping them in check. Well, if nobody's keeping them in check, then they can eat all the grasshoppers that they want to. And eventually, if they eat up all the grasshoppers, then they run out of food. Okay, so then they start to die off. And then as they die off, you'll find later on, we'll talk about as one population dies off, it gives the other population a chance to regenerate. So you have this kind of up and down flux thing that will happen, but we'll look at that later. All right, so yes, we are leaving. All right, so the other one I want you to look at um is this one. That's not the one I want you to look at. So we're not gonna, not yet. We're gonna come back to that at the end of class. That's the matching. So you got to pay attention, because what I'm gonna want you to do with that later is not when you finish matching it, you're gonna have to upload your completed tile for me. That's not the one. Okay, so that's application. Let's look at this one. All right, so I just put the link for this one in the chat. So if everybody could log into that one. All right, so this one just has a couple of questions it wants to ask you. All right, so I'll give you a minute for everybody to answer that, and then I'll check the teacher page to see who's answered and who hasn't. Do you think that an energy pyramid graphic provides the same information as a food chain? In other words, the picture of the pyramid, is that going to give you the same information as drawing a line of animals all in a row? What do you think? All right, William, you with us? I need an answer. Thank you. All right. Now remember, in our pyramid, the pyramid shows our producer. The next level on the pyramid shows the primary consumer, or the thing that eats the grass, then it shows the one that eats the herbivore that eats that, and then it shows the tertiary consumer. Food chain is going to show you basically the same thing. So everybody who said B is correct. It is going to show you the same thing. It just looks different. But basically all food webs have to start with a producer. And then the arrow is going to go to who eats the, the plant. So that will be your next level, your primary consumer. And then the arrow will go to the one that ate the primary consumer, and then so on and so forth. So the food chain looks exactly like a pyramid, except it's not wide. Okay. Okay. All right. So reviewing this one as well. This is one way to show the transfer of energy. And that's the other concept that you have to put in your head, that the pyramid and the arrows show the transfer of energy from one organism to the next. So that is the whole point, is energy transfer. Okay. And producers make up the base. So when we're drawing a pyramid, they make up the base. But if you're doing a food chain, they are always the first organism in your food chain. All right, so we look at this. You have to remember way back from before with the energy, the law of conservation of energy says energy is not created or destroyed. That's a law. All the energy that is in the universe is in the universe, and it is just recycled. Okay, so the plants take it in, and then some energy is lost to the environment, but in losing it to the environment, it's absorbed somewhere else. And the energy that's stored in the plant is then recycled to the next level. And then when they die and they decompose, they return the energy back as well. So it's cycled. Nothing is newly created. It is just recycled. All right, again, we have to remember again that 90% of the energy that enters the organism, and there's the numbers that I was talking about before. So again, later on, when you actually have a quiz or test, they will give you numbers and ask you what do you expect the number on the next level to be? And what you need to remember is the easy way is to just keep dropping a zero. But they're going to be 10% of the level before it. So where you had 10,000, now you have 1,000 in the first level. You drop a zero, you got 100. You drop a zero, you got 10. So dropping a zero on each level is the easiest way without having to do a whole lot of math to express the fact that only 10% of the energy is stored. 90% of the energy is being used by the organism. Some of that energy is being not just used, but some of it's being lost to the environment. And again, when we say lost, it's not really lost, even though it's lost to the organism, it's lost to the next level because they don't get it, but it's lost to the environment. So there's two places it's transferred. It's either transferred to the next level or lost to the environment. Okay. Okay. All right, and this is a review. So it is the energy is created by the primary consumers, and when we say, then it is transferred to the next consumer, and then some of it is lost due to heat energy. All right, so take a minute to read that over. When again, available energy decreases by 10% as you go up the pyramid. And the last one is important. It takes a large number of primary consumers to support a small number of secondary consumers. So this is why we use the pyramid to show that you need that base. You need a large number of organisms just to support the organisms above. The pyramid looks, Sadie's asking if the pyramid is more complex. It looks more complex because it gives you say bigger picture. But a food chain is more specific because it's giving you the specific organisms that are being involved. So you could take those organisms in a food chain and put them on a pyramid, okay, and then tell the same story. So it just looks more complex. And when we talk about food pyramids, we're more specifically talking about the energy transfer as opposed to the feeding relationship. So I guess if you want to look at it that way, it's more complex. Okay. So when we look at the pyramid, it's more to look at energy transfer. But again, when you draw a food chain or a food web, the arrows also indicate energy transfer. All right. So it says, let's create. You are going to you're going to create an energy pyramid, and you are going to use kelp, which is like seaweed, and you're going to use small fish, mackerel, and tuna, and a shark. And so you actually have to draw a pyramid and add these organisms in where they belong. Okay, so I'm going to switch to student mode and leave it right there so everybody's not watching you draw. You might have do you have a tool where you can actually create the pyramid so that it's nice and neat? And then you can type the words in. Do you have a tool that you can do that? Does Nearpod allow you to do that? I guess it's the better question. Yes, you can. Yes, you can. You can type using the text tool. You probably do have to use the um, marker for drawing the pyramid. Let's see. Okay. So yeah. So once you draw your pyramid, we'll click on that. Let's make it and be creative. What you can do is and I'm not artistic either, so we can't say, but I'm not good at drawing. All right, so we have 1, 2, 3, 4, 5. So we need 5 levels. So I need to divide my pyramid into 5 portions. Okay. So for starters, it should look like that. And then you just have to place those 5 organisms where they belong. And again, use the text tool. Again, you always want to make sure that, and with the text tool, you can make the box big, small. You can move it where you want it to go. So I'll give you another minute before I start filling mine in to see what yours looks like. All right, let me take a peek at yours. Oh, all right, Van, what happened? You got your words. I don't see the pyramid. Okay, there you go. All right, you're working on it. I got you. All right. Journey, look like you're trying to draw the organisms in there. You can just put a word. You don't have to just put a word. Just put a word. Everybody isn't logged in either. Two of y'all ain't logged in. Isadora, I'm gonna start marking you absent if you keep turning your camera on and just disappearing on me. And that goes for everybody. And if you need to leave the room, you just tell me I'm leaving the room for a minute and then come back. But don't log in and then I'm looking at the ceiling and then you never participate in any of the activities because then I know you're really not in class. Okay. And I might just go back and mark you absent in the grade book and you're talking about, but I logged in, but no, but you weren't. Okay. All right, so let me come back to mine. And so a lot of you are good. You're good. You're good. So what you should have is your producer, which is the kelp, your seaweed, and they should be at the bottom. And then your next level, that what eats the kelp will be the small fish. So that will always be what you have next. And in answer to Sadie's question, we could turn around and then draw this as a food chain as well. So that we're going to type our small fish in here. Oops, I can't spell. And then who eats the small fish? The mackerel. The mackerel is just a slightly bigger fish, but it's not the biggest fish. So we have and then and the thing with doing text boxes and typing is you can easily shift your words. So we want to center this so that it looks more like one word is on top of the other. Oops. I don't know why I'm wasting time doing that, but okay, just so it looks neat. Then we put our tuna here. So this is what yours should look like when you're finished. And again, you could have drawn this as this asks you to do a pyramid, but you could still do this as okay. All right, well, I need you to participate, Isadora. You can't just keep checking out on me like that. And you need to tell me when you're leaving, because when I do checks like that and you're not there, I don't know why you're gone. Okay, and our shark is at the top. So our shark is listed as our apex predator. Things don't usually eat the shark. The shark is our tertiary consumer. Top of the pyramid, or top of the food chain, as they say in Nemo. Okay, so sharks eat tuna, tunas eat mackerel, mackerels eat small fish, and small fish eat kelp. And as we go up, again, there are fewer sharks in the ocean than there are kelp. There's a whole lot more kelp than there are sharks. And the sharks don't eat kelp, they eat tuna. So if for some reason we take the tuna out for this, the shark can eat the mackerel, but that's going to mess up the uh, food pyramid for the small fish because while the sharks are eating the mackerel, the small fish population can just boom, which is not good for the kelp because eventually the kelp we will it's kind of like having the cows overgrazing a field. That's what would happen there. That eventually it affects. So taking one organism out of the food chain affects other organisms. And again, we're only looking at one set of feeding relationships. There are other organisms in there. All right, so let's do this quiz. There are 10 questions in the quiz, and I want to see everybody's results. So I'll give you 10 minutes. Run to the restroom and come back. Come back. All right, so take the class ends at 1:25. So let's try to get this finished before 1:25. There are 10 questions. When you answer one, just hit next, and it'll take you to the next question. When you get to the end, I'll see the score on my teacher page. All right. So I'm gonna let you work on that. My advancing doesn't affect you, right? I'm gonna stop sharing for me while you do that. Okay, if you finish your quiz, you can go ahead and log out, and I'll see you tomorrow.